Hi all, very happy afternoon to each and every one. Very happy afternoon. We were discussing perfect squares problems. Perfect square problems. In case if you are somebody who has not attended perfect squares session number 1, kindly watch perfect square session number 1. Perfect square session number 1, we discussed all the fundamentals in perfect square session number 1. Now here in session number 2, we will cover more of problems and the concepts we discussed in session number 1. In case if you are live right now, kindly use the chat option and reply with an yes. Reply with an yes in case if you got a notification. Right. How many of you have attended perfect square session number 1? In case you attended perfect square session number 1, reply with an yes. Then we are getting into session number 2. Perfect squares is an extremely important topic taken from number system. These will be the important key points. Kindly watch the first basics class, then get into the application. These are some demo live classes that we are conducting so that the students can listen to our style of teaching and they can enroll for any of our online courses. Actual batch will start from January 1st, where topic wise live classes will be discussed. January 1st. Kindly reply with an yes in case if you have attended the session number 1. Let us not waste time. This is the lesson structure that we follow in every class of mine. First we will start with the definition related problems, then some foundation questions, then intermediate level questions, then advanced level problems, then exam model questions solved. This will be the structure that we will follow in every class. What are the concepts that we discussed? We have taken the concept that is perfect square. What are all the important concepts with respect to perfect square? Let us see. A perfect square is a number multiplied by itself. It is a perfect square. A perfect square, the power will always be an even number including 0. Because a number is multiplied by itself, obviously the power will be an even number including 0. A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. Another concept we discussed. What is the next concept? The digital sum of a perfect square. The digital sum of a perfect square is always 1, 4, 7 or 9. It is always 1, 4, 7 or 9. And a perfect square, any perfect square will be of the form either perfectly divisible by 4 or it gives a remainder 1. Either perfectly divisible by 4 or it gives a remainder 1. These are some of the concepts which we discussed in session number 1. In case if you are a student watching the session number 2, right, please right after the session number 1 video is processed, go back and watch session number 1. Then watch session number 2. Then it will be very effective. If anybody is watching the class right now, Rohit or Pranita or Satvika, let me know in case if you are facing any audio issues. Is audio perfectly clear? Any audio issues? Any streaming issues? Once you say no issues, then we are ready to go. Very interesting class. We are going to discuss. More and more classes you attend, more and more clarity you will get on the concepts. Everybody kindly. Satvika says no issues. So in session number 1, what are the concepts that we discussed? So we discussed question number 1, question number 2, 3, 4, all these problems we discussed multiple ways. So till which question we solved? Till this question we solved it. In this question we discussed the multiple model, how to use the number tree concept, how to use the unit digit concept, how to use the last digit concept, how to simplify the problem. Next one. In this class we will solve another 15 to 20 questions. How many numbers are of the form 1, 11, 111 and so on? These 1, these 11, how many numbers are of the set? 111 and so on, 4 ones, 5 ones and so on. How many numbers in this set are perfect square? Listen carefully, sir. The root cause of the problem is it is a perfect square. Perfect square will always be of the form 4k or 4k plus 1. 4k or 4k plus 1. That means what is the divisibility rule of 4? Last 2 digits should be divisible by 4. Divisibility rule of 4. Why we are using divisibility rule for 4? The reason is perfect square is always divisible by 4 or it gives a remainder 1 when divided by 4. Divisibility rule of 4. Last 2 digits should be divisible by 4. Last 2 digits should be divisible by 4. Last 2 digits should be divisible by 4. So 1 it is a perfect square. 1 square is equivalent to 1. It is a perfect square. 11 is 4 into 2 plus 3. 4k plus 3 form. Last 2 digits here also. 11 is a 4 into 2 plus 3. From second number onwards, all the numbers are of the form 4k plus 3. All the numbers are of the form 4k plus 3. Any perfect square cannot be in the form 4k plus 3. So answer is only one number is a perfect square and that number is 1. 11 is 4 into 2 plus 3. 4k plus 3 form does not arise. Even in 111, last 2 digits is 11. 4 into 2 plus 3, that form will not arise. 4 ones, last 2 digits is 1. Everywhere starting from the second number, last 2 digits is always 1. 4 into 2 plus 3. 4k plus 3 does not arise. So answer is only one number is a perfect square and the first number is the first number. Second one. How many numbers are of the set 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. This pattern is continuing. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 7, till 9 it is. 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many elements in the set are perfect square? Very, very good question. How many elements in the set are perfect square? We know the properties of a perfect square. Let us use it. A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. It cannot end with 2. It cannot end with 3. It cannot end with 7. It cannot end with 8. So, few numbers are eliminated because of the property. Perfect square never ends with 2, 3, 7 or 8. Any perfect square ending with 5, tens place is always 2. 5 square 25, 15 square 225. Any perfect square ending with 5, tens place is always 2. So, this number it is eliminated. Next one, what are the other cases? 1, 2, 3, 4, it is eliminated. 34 is 4 into 8 plus 2. Any perfect square when divided by 4 perfectly divisible or it gives a remainder 1. So 1, 2, 3, 4 eliminated. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Now what are we left with? 1. Next number is 1, 2, 3, 4, 5, 6. And the next number is 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I hope the logic it is clear. So here it is 1, 1 square it is 1. 1 it is a perfect square. 1 it is a perfect square. 1, 2, 3, 4, 5, 6. What is the digital sum? 6 plus 3, 9. 5 plus 4, 9. 9 plus 9, 18. 18 plus 3, 21. 21 digital sum is 3. A perfect square digital sum should be 147 or 9. 147 or 9. So it is 3. So these are not possible. These are not possible. 9, 17, 24, 30, 35, 35, 39, 42, 44, 49. These digital sum is 9. It may or may not be a perfect square. It may or may not be a perfect square. Now listen carefully, sir. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now if you see from here, what are the last two digits of a number? 18, 9. 17 square is 289. Last two digits it is 89. So 17 square is 289. What? Now here if we will do one logic, how to find the number of digits in the square root of this number, I will explain this logic, then I will come back to it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Very interesting. First I will explain the concept, then we will see whether the number is a perfect square or not. Then the number is a perfect square or not. Let me use a empty slide, then I will explain a concept. Now listen carefully. Concept. Very interesting concept. First one, concept 1. How to find the square root of a perfect square. How to find the square root of a perfect square. Concept 2. How to find the square root of a non-perfect square. Now listen carefully. Multiple examples I will solve. First one, square root of, for example, 3136. Square root of 3136. Any number which does not obey that property of digital sum should be 147 or 9. If it is not 147 or 9 digital sum, then the number is not a perfect square. Square root of 3136. Step number 1. Listen carefully. Start from rightmost. Keep a slash after 2 digits. How many blocks of 2 digits are there? 36 is a block of 2 digits. 31 is a block of 2 digits. So answer will have 2 digits. Suppose for example, if it is 1, 2, 5, 4, it is there. 1, 2, 5, 4, it is there. Take a group of 2 digits. One can be written as 0, 1. So how many block of 2 digits are there? 3 blocks are there. 44 is 1 block. 25 it is another block. 1 can be written as 0, 1. So finding the number of digits. How will you find the number of digits? How will you find it? Start from right hand side. Take a group of 2 digits. Take a group of 2 digits. How many blocks are there? To take a group of 2 digits, which we call it as a block. How many blocks are there? That many digits will be there in the answer. I hope it is clear. Suppose if the question is like this, square root of, for example, 976144. How many blocks are there? 1 block, second block, third block. Answer will have 3 digits. Now let us do one logic. Then we will get the answer very easily. How to find the number of digits in the answer? Start from the right hand side. Take a group of 2 digits. I will call it as a block. Suppose if there is single digit, prefix is 0. Square root of 3136. What is the another logic that we discussed right now? Another logic which we discussed in the first session is x square 50 plus or minus x whole square. 50 plus or minus x whole square. 100 plus or minus x whole square. X square 50 plus or minus x whole square. 100 plus or minus x whole square. Last two digits will be same. Last two digits will be same. X square 50 plus or minus x whole square 100 plus or minus x whole square. Last two digits will be same. If you know this logic, you will get the answer very easily. 36. What is the smallest number? On square, I will get 36. 6 square is 36. So, 50 plus 6 square. 56 square is 3136. 56 square is 3136. Easily you will get the answer. Sir, can't I take 100 minus 6 square? 100 minus 6 square is 94 square. 94 square is greater than, right? 8100. Number is around 3000 range. 3000 number, which number I will get? 6 square is 36. 50 minus 6 is 44 square. 50 square is 2500. So answer should be greater than 50. So it is 56. Idea clear? So if it is 44, what is the smallest number? On square, I will get 44. 12 square is 144. 50 minus 12, smaller number. 50 plus 12, 62 square. 3000, it is 100 minus 12, 88 square, smaller number. 100 plus 12, 112. 112. You don't need to do anything. 112. 44. 44 square is 12 square 144. 12 square 144. This entire number, it is entire number is in the range of 10 lakhs. So not only for 50 plus or minus x whole square, 50 multiples, 100 plus or minus x whole square, 150 plus or minus x whole square, 1000 plus or minus x whole square, 1000 minus 12, 988. 988 square is 976144. 976144. I hope the logic it is clear. What we are doing it? First we are identifying the last two digits of a number. 36. 6 square is 36. 50 plus 6, 50 minus 6. 50 minus 6 is 44 square, which is a smaller number. 56 square is 3136. 56. Directly you can find it out. Another way in textbook they will tell you is 31 lies between which two squares? 5 square 25 and 6 square 36. Take the smallest number. Smallest number is 5. 36 means it is 6. 125 lies between which two numbers? 11 square is 121. 12 square is 144. Take the smallest number. Smallest number is 11. Smallest number is 11. Are you all with me? Very, very good problems. Must and should attend the problems. Right? We will do another few examples. Please tell this. If you observe, all these number has a digital sum. 1, 4, 7 or 9. 6 plus 3, 9. 9 plus 3, 12. 12 plus 1, 13. 13 it is 4. 8 plus 5, 13. 15, 16, 16 it is 7. If a number is a perfect square, it should have digital sum 1, 4, 7 or 9. It should have a digital sum 1, 4, 7 or 9. Please drop your pens and tell me this answer. Square root of, for example, 2304. Square root of 2304. Square root of 7569. Square root of 100,489. Square root of 1521. Square root of 1521. Square root of 5329. All of these numbers are perfect square. How to find the square root of a perfect square? How to find the square root of a perfect square? This is the logic that we are discussing. How to find the square root of a perfect square? Listen carefully, sir. Square root of 2304. First identify the last two digits. 04. What is the smallest number on square? I will get 04. 2 square is 04. Then execute the logic. X square 50 plus or minus x whole square. X square 50 plus or minus x whole square. 100 plus or minus x whole square. Last two digits will be same. Last two digits will be same. Last two digits will be same. So it is 2 square 04. 50 plus 2, 52 square. 52 square is greater than 2400. So 50 minus 2, 48. Answer is 48. Answer is 48. Square root of 7569. What are the last two digits? 69. Which number on square I will get 69? 13 square is 169. 13 square is 169. So x is 13. It is 7500 range. 50 plus 13 is 63 square. 63 is not in the form of 7300. 100 minus 13. Answer is 87. 100 minus 13. Answer is 87. I hope the logic is clear. These 89. 17 square is 289. So x value it is 17. X value it is 17. 50, 100 plus 17, 117 square. No. 200 plus 17, it is around 40,000 range. 300 square is 1 followed by 4 zeros. 1 followed by 4 zeros. So these 317 square. These 317 square. 3 it is 9, 9 followed by. So these 1 lakh is greater than 90,000. So answer is 317 square. 1521. Last two digits is 21. 11 square is 121. So 11, 50 minus 11 is 39. 39 square is 1521. Idea clear? 5329. Last two digits it is 29. Which number on square ends with 29? 23 square is 529. 50 minus 23. 27 square, it will be a smaller number. 50 plus 23. It is 73. I hope this concept it is clear. Anybody who got a doubt how to find out the square root of a perfect square using last two digits logic? Using last two digits logic, kindly mention. This is 04. 2 square it is 04. 50 minus 2 is 48. 48 square is 2304. 7569. 13 square is 169. 100. Dhanraj? Any issues? ఇంటర్నెట్ ఆఫ్ ఉందా? ఇంటర్నెట్ లేదు ధనరాజ్. Any issues students are facing? Any issues? Can you all hear me? Any audio issues? Is it clear right now? Kindly reply if everything is clear, then we will get into the class. There was a power cut for some time. Rohit, is it clear? In case if there are any power cut issues, just wait for 2 minutes till the UPS is on, then we will resume the class. Is the class clear? I hope can you see the screen? I hope you can hear the audio clearly. You can hear the audio clearly. Everybody kindly reply. Kindly reply in case of any streaming issues. Are we all ready to go? Shall we all start the class? Kindly reply. Where are we? We are finding the square root of a, let me open the slide. We are finding the square root of a perfect square. Few more examples, let me see. How to find the square root of a perfect square. How to find the square root of a perfect square. Then we will look into the non-perfect square. Example, square root of 3481. Square root of 8464. Square root of 171396. 171396. Square root of 3481. Square root of 8464. Square root of 171396. 81. 9 square, it is 81. So x square 50 plus or minus x whole square, or 100 plus or minus x whole square. Last two digits will be same. 3481 is just greater than 2500. So answer is 50 plus 9, 59. Answer is 59. 8464, keep a slash after two digits. 8 square is 64. 8,400 is greater than 8,100. 100 minus 80 is 92. 100 minus 80 is 92. 171396. This is 96. 14 square is 196. So x value it is 14. This is close to 1,71,000. So if I take 16 followed by 4 zeros, this is 400 square. Answer should be just greater than 400. 400 plus 14. Answer is 414. Answer is 414. I hope the logic it is clear. 9 square 81. 50 plus 9 59. 8 square 64. 100 minus 8 92. 14 square is 196. That number C, where the number is just greater than, take the logic. Square root of a perfect square. I hope the logic is reply. Kindly reply with yes in case if it is clear to you. In case if it is perfectly clear to you, kindly reply with yes. Kindly reply with yes. Wherever the digital sum of a number, if it is 1, 4, 7 or 9, please check it out whether it is satisfying all the properties of a perfect square. Then go ahead. Everybody kindly reply. Now, sir, what if it is a non-perfect square? What if it is a non-perfect square? Two logics are there. We will discuss one logic. How to find the square root of a non-perfect square. How to find the square root of a non-perfect square. How to identify whether a number is a perfect square or a non-perfect square depending upon the properties. Root 13 is there. A perfect square never ends with 2, 3, 7 or 8. Root 39 is there. Digital sum of 39 is 3 plus 9, 12, 1 plus 2, 3. Perfect square digital sum will always be 1, 4, 7 or 9. Root of 188 it is there. Perfect square never ends with 2, 3, 7 or 8. So like this you can see how to find whether a number is a perfect square or not. Root 13 lies between root 9 and root 16. So answer is 3 plus 13 9 difference is 4. 16 9 difference is 7. So answer will be close to 7 5s are 35, 50, close to 3.57. Answer is close to 3.57. Root 39 lies between which two numbers? Root 36 and root 49. So answer is greater than 6. 6 plus 39, 36, 3. 49, 36, it is 13. So answer is close to 6, 3 by 13. Answer is close to 6, 3 by 13. Root 188. It lies between 13 square is 169. 14 square is 196. So answer is 13 plus 189, 169. It is 19. 196, 169. Difference is 27. So answer is very, very close to 1319 by 27. Answer is very, very close to 1319 by 27. So here again I am explaining. Root 9 it is 3 plus 13 9 it is 4. 16 9 difference is 7. So answer is 3 plus 4 by 7. These are all approximated values of a non-perfect square. This is how you can find the approximated value of a non-perfect square. Root 39 lies between root 36 and root 49. 6 plus 39, 36, 3. 49, 36, 13. Answer is very close to 6, 3 by 13. Answer is very, very close to 6, 3 by 13. I hope the logic is clear. Now based upon this one, let us solve some more very interesting problems. How many numbers of the set? 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. Let us use the concept of a digital sum. Digital sum of a perfect square. Digital sum of a perfect square is always 1, 4, 7 or 9. Digital sum of a perfect square is always 1, 4, 7 or 9. 4 plus 4, 8. Digital sum. 4 plus 4, 8. Digital sum is always 1, 4, 7 or 9. 4 plus 4 plus 4, 12. 12 it is 3. So it is not a perfect square. 4 plus 4 plus 4 plus 4, 16, 16, 7. Chances are there. 4, 4, 4, 4, 4. 4 5s are 20, 22. These no chance it is there. So we are left with 4, 44, 44. 44, 44. How many elements in the set are perfect squares? How many elements in the set are perfect square? Definitely 4 it is 2 square. 2 square it is 0, 4. 2 square it is 0, 4. 44, 44. These ending with 44. 12 square is 144. Already we have seen. 50 minus 12, 38 square. 50 plus 12, 62 square. 100 minus 12, 88 square. 38 square is 1,444. 62 square is, if you are good in calculation, 3844. 88 square is 7744. 7744. This number is not coming as a perfect square. How many elements are perfect squares? Only one element. Only one element. And that element it is 4. Only one element, it is a perfect square, and that element is 4. I hope the logic is clear. Again I am repeating. How many numbers of the set? 4, 44, 444, 4 4s and 5 4s. Double 4, digital sum is 8, not possible. 4 4 4, digital sum is 4 plus 4 plus 4, 12. 12 it is 3. It is not possible. 4 5s are 20. 20 it is 2. It is not possible. These eliminated, these eliminated, these eliminated. So either this or this. 4 4 4 4 4, that value is not coming. 44 last two digits of a number. 12 square 144. 50 minus 12, 50 plus 12, 100 minus 12. None of the cases I am getting that number. So only one element it is a perfect square, and that value it is 4. I hope the idea it is clear. Next one, square root of which of the following it is a rational number. We have to tell which of the following options it is a perfect square. Which of the following options it is a perfect square. What are the properties? Perfect square never ends with 2, 3, 7 or 8. These out. Perfect square never ends with 2, 3, 7 or 8. It is out. A perfect square digital sum. A perfect square digital sum will always be 1, 4, 7 or 9. Perfect square digital sum will always be 1, 4, 7 or 9. This is 9. 5 plus 4, 9. 9 plus 9, 18. 18 plus 8, 26. 2 plus 6, 8. Not possible. 9. 5 plus 4, 9. 1 plus 2, 3. If the digital sum is 3, how can it be a perfect square? 5 plus 4, 9. 1 plus 3, 4. 4 plus 2, 6. 6 plus 4, 10. 10 digital sum is 1. There is a choice. So answer for this question is C. Very, very easy question. If I use 2 properties, I will get the answer. What are the 2 properties? Perfect square never ends with 2, 3, 7 or 8. Digital sum of a perfect square is always perfect square. A perfect square digital sum is always 1, 4, 7 or 9. 1, 4, 7 or 9. I hope the logic is clear. Similarly, you can use this logic. The square root of which of the following is a rational number. Same example. Perfect square. A perfect square, what are all the properties? A perfect square never ends with 2, 3, 7 or 8. It is ending with 2. Not possible. A perfect square digital sum will be 1, 4, 7 or 9. A perfect square digital sum will be 1, 4, 7 or 9. 3 plus 4, 7. 7 plus 7, 14. 14 plus 4, 18. 18 it is 9. 18 it is 9. So 5 plus 4, 9. 9 plus 2, 11. 11 plus 1, 12. 12 plus 13, 25. 7. 25 it is 7. 9. 9 plus 6, 15. 15 plus 4, 18. 18 plus 4, 22. 22 plus 3, 25, 2 plus 5, 7. So here it is giving digital sum 9, here it is giving digital sum 7 plus 4, 11, 11 plus 1, 12, 12 plus 13, 25, 7. Here it is giving 15, 19, 7, 11, 20, 20. Let's see here 15, 15 plus 8, 23. Sorry, it is giving digital sum 8. Not possible. So I am struck with 304704 and the next one is 524.176. 524. Now you know how to do the logic. It is 4. So 2 square is 04. It is 2 square is 04. So this is close to about which number, how many digits will be there in this number? 1, 2, 3. 1, 2, 3. 3047. It is a 4-digit number close to 3000. Close to 3000 means which number it is? 50 square is 2500. 55 square is 3025. So that means 55 square is 3025. 60 square is 3600. It lies between these two. So let us check. What is 552 square? 552 square. If 552 square is this number, if 552 square is this number, then we will get the answer. So 552 square, you don't need to compute. Let us do it by using digital sum. 304704. 5 plus 5, 10. 10 plus 2, 12. 12 it is 3. 3 square it is 9. What is the digital sum of this number? 11, 15, 18. It is coming to be 9. 552 square, find it out. A will be 555, 55, 2AB and the next one will be B square. Are you all with me? A square, 2AB and B square. 55 square is 3025. 55 4s are 220. 2 square it is 4. Write 4022. It is 304704. How to do the square of a number? Square of a number can be done by using a plus b whole square. A square, 2ab and b square. A is 55 and b is 2. 55 square, 2 into 55 into 2 and 2 square. 55 square is 3025. 55 into 4 is 220 and 4. Write down the unit digit in 4. 220 unit digit is 0. 22 carried. 3025 plus 22 is 3047. 3047. I hope the idea it is clear. I hope the idea it is clear. Another one, if you observe closely, 23 square is 529. 2.3 whole square will be 5.29. That means after dot 1 digit it is there. After dot there will be 2 digits. After dot if there are 2 digits. On square I will get 4 digits. That means after dot even number of digits will be there. After dot even number of digits will be there. After dot even number of digits will be there. After dot there are odd number of digits. These is not possible. That also can be done. Very, very good exam replica question, sir. Exam replica question. 304704. First of all, digital sum of a perfect square should always be 1, 4, 7 or 9. Wherever it is not 1, 4, 7 or 9, eliminate it, then use these logic. 2 questions. I hope you got a very, very good clarity on solving this question. Right after the class is over, the video will go through an encryption mode. You can see it under the live classes. Once the video is processed, you can watch it. How many 5-digit perfect squares can be formed using the digits? Exactly once. First of all, I need to find a 5-digit number. 5-digit number is like this, and the number should be a perfect square. The number should be a perfect square. 5 digits. How many digits are there? 1, 2, 3, 4, 5. How many places are there? 5 places are there. 5 digits are there, 5 places are there. So this can be any one out of the 5 digits will come. 1 digit is already placed. Any one out of the 4 digits will come. Any one out of the 3 digits will come. Any one out of the 2 digits will come. any one. So total 120 numbers are there. Total 120 numbers are there. Out of these 120 numbers, how many perfect squares are there? One logic is to check every number whether it is a perfect square or not, or go by these logic. Can I say one number will be like this? 1, 2, 3, 4, 5. Another number can be like this, 5, 4, 3, 2, 1. Exactly once. Or one number can be like this, 1, 5, 2, 3, 4. Another number can be like this, 2, 5, 3, 1, 4, and so on and so on. Am I right? Now, if you simple observation, perfect square, what is the logic related to perfect square? A perfect square digital sum is always 1, 4, 7 or 9. A perfect square digital sum is always 1, 4, 7 or 9. Let us do the digital sum. 5 plus 4, 9, 9 plus 3, 12, 12 plus 2, 14, 14 plus 1, 15. 15 digital sum is 6. Even if you change the order of the digits, 1 plus 2 plus 3 plus 4 plus 5 is also equivalent to 5 plus 4 plus 3 plus 2 plus 1. 5 plus 4, 9, 9 plus 3, 12, 12 plus 2, 14, 14 plus 1, 15. 15 digital sum is 6. So, all the 120 numbers, digital sum will be 6. If it is 6, what is the nature of a perfect square? Digital sum should be 1, 4, 7 or 9. So, answer is no perfect squares are there. Answer will be no perfect square exists satisfying this condition. No perfect square exists satisfying this condition. 5-digit numbers are there. How many 5-digit perfect squares are there? Numbers that are used are 1, 2, 3, 4, 5. Totally 120 numbers that can be formed. One number will be of the form 1, 2, 3, 4, 5. Another number 5, 4, 3, 2, 1. Sum of the digits is always 6 irrespective of how you add the digits. Perfect square digital sum will always be 1, 4, 7 or 9. According to the question, it will be 6. Therefore, the answer is not a perfect square. I hope the idea it is clear. Next one, read this question. Each number, read the question, sir. Each member of a picnic party, okay, let there are X numbers, contributed twice as many rupees as the total number of numbers. Assume there are total X people. Each number contributed twice. Twice is 2 times. Twice the number of members. Total numbers are members. So, total contribution will be 2x square. Total contribution will be 2x square. X is the total number of members. Each member contributed. These each member's contribution. Each member's contribution. It is total 3042. So, 2x square equivalent to 3042. So, x square will be 1521. 1521. 1521 it is an odd number. Something on square it will be an odd number. So, x will be an odd number. Odd number on square only I will get an odd number. Odd number on square only I will get an odd number. So, answer even all are out. 230 to 50. I hope it is clear. Even if I take 39 square, 39 square, suppose if there is another number 29, you don't need to find out. 39 is 50 minus 11 square. X square 50 minus x square. X square 50 minus x square. Last 2 digits are same. X square 50 minus x square. Last 2 digits are same. So, if it is 39, 50 minus 11 square. So, 11 square is 121. Last 2 digits are 21. It is matching. Therefore, answer for this question is 39. Therefore, answer for this question is 39. What we are doing here is, we are just converting the statement, these entire statement into a mathematical expression. Total number of members that went into for a picnic are X. Each member gave twice the number of members, 2x. Total collection is 3042. 2x square it is 3042, x square it is 1521. 1521 it is an odd number. Odd number on square only I will get an odd number. So 2, 32, 40 are eliminated. 39 square you don't need to find out. Check by using the last two digits logic. X square 50 minus x square. Last two digits are same. 39 is 50 minus 11 square. 11 square is 121. Last two digits are same. Last two digits are same. I hope the idea it is clear. Next one. 1008 divided by which single digit number gives a perfect square? Gives a perfect square. 1008 divided by which single digit number gives a perfect square? Simple substitution of the answer will give you the logic. First one, 1008 divided by 9. So this will be 9 11s are 99 2. It is 112. Any perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. It is ending with 2. Not possible. Right. Next one. 1008 divided by 4. 1008. See, you don't need to do all these. What is the unit digit in the numerator? 8. Denominator, I took the first option, 9. 9, which all numbers it will give? 8 at the end. 9 2s are 18. So it is ending with 2. 9 3s are 27, 9 4s are 36, 9 5s are 45, 9 6s are 54, 9 7s are 63, 9 8s are 72, 9 9s are 81. To get 8, unit digit has to be 2. It is not possible. It is ending with 4. For which multiple it will give you 8. 4 2s are 8. 4 7s are 28. So that means unit digit will be either 2 or 7. Perfect square never ends with 2, 3, 7 or 8. 4 not possible. Next one, 1008 divided by 8. 1008 divided by 8. This will be 8 12s are 96, 48, 8 6 are 48, 126. 126. Last two digits is 26. 4 into 6 plus 2. 4k plus 2 form is not possible for a perfect square. Is not possible for a perfect square. Idea it is clear. 1008 divided by 9. 9 which multiple I will get? 8. 9 2s are 18. That means unit digit will be 2. Not possible. 1008 divided by 4. 4 2s are 8. 4 7s are 28. Per unit digit will be 2 or 7. Not possible. 8 I am getting 126. 126. Last two digits is 26. 4 into 6 plus 2. 4k plus 2 form does not arise. If I check it out, 1008 divided by 7. 144. 144 it is a perfect square, which is 12 square. I hope the idea it is clear. Next one. By which smallest number should 5808 should be multiplied? One is a division, we did it, such that it becomes a perfect square. 5808 into x, it should be a perfect square. Listen carefully, sir. Very interesting. Once you know the concept of perfect squares, you can use it very, very easily. What is the unit digit of this number? 8. Third option, it is 11. Unit digit, it is 1. 8 1s are 8. A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. These are not possible. These are not possible. What is the digital sum of 5808? 5808 digital sum will be 8 plus 8 16. 16 plus 5 21. 21 it is 3. First option it is 2. 3 2s are 6. But a perfect square digital sum will be 1 4 7 or 9. A perfect square digital sum will be 1 4 7 or 9. First option not possible. Are you all with me? Second option, digital sum is 3. 3 sevens are 21. 21 digital sum is 3. 21 digital sum is 3. Perfect square digital sum is always 1, 4, 7 or 9. This is not possible. So answer is 3. I hope the idea it is clear. So very interestingly, we can use the digital perfect square properties what we discussed in session number 1 and we can use it. 5808, 8 plus 8 16, 16 plus 5 21. These is 3. These digital sum is 2. 3 2s are 6. 6. Perfect square digital sum is always 1, 4, 7 or 9. 2 not possible. 3 sevens are 21. 2 plus 1, 3 not possible. So anyway perfect square never ends with 2, 3, 7 or 8. 11 is out. Option it is 3. By using digital sum without even factorization, we can use the logic. Which of one of the following is not a square of any natural number? Square of any natural number is called a perfect square. So which one of the following is not a perfect square? Which one of the following is not a perfect square? One by one we will discuss. Now see here. A perfect square never ends with 2, 3, 7 or 8. These out. Next one. 6 plus 5, 11. 11 plus 9, 20. 20 plus 8, 28. Digital sum it is 1. There is a chance. First one there is a chance. 18225. 7 plus 2, 9. 9 plus 9, 18. 18 it is 9. Second one also there is a chance. 7 plus 3, 10. 10 plus 8, 18. Fourth one also there is a chance. Fourth one also there is a chance. Now how you will do it? Very easy. 17956. 17956. 56. Last two digits are 56. What is the smallest number on square? I will get 56. 16 square is 256. 16 square is 256. So which logic you will use? X square 50 plus or minus x whole square. 100 plus or minus x whole square. Last two digits will be same. Last two digits will be same. 16 square is 256. So square root of 17956. Keep a slash after two digits. 13 square is 169. 14 square is 196. So these two, which number it is ending with 56. Just check it out. 16 square is 256. 16 square is 256. So 50 plus these, which number it is close to? 18,000 it is. 18,000. So check it out. 18,000 where it is? 16. 84 these. 13 square 169 and 14 square 196. So these last two digits will be 13. Now here 256. So it is, check it out with 146 square. 146 square. 146 150 sorry 16 square is 256. 150 minus 16 is 134 square. 134 square. Check it out by using 134 square. I hope the logic is clear. If 1, 3, 4, 5, 6 question is not right, okay, that is the reason. Not anyway it is 63592. 63592. I will show you with an example of 18225. 18225 square root. 5 square it is 25. 182 lies between 13 square is 169, 14 square is 196. So it is 135. 135 whole square is 5 square 25, 13 into 14 is 18225. Even if you do the square, you will get the answer. Very, very good problems where we are using the properties of a perfect square. I hope the logic it is clear. Similarly, here also try to do. Square root of 53361. Last two digits is 61. 61 is 19 square is 361. 19 square is 361. 533. 533 lies between which all numbers? 23 square 529 and 24 square 576. So try it out with 239 square or 231 square. One should be helpful for your answer. Now if you see here, 239 square is not possible. 39 square is 11 less than 50. 11 square is 121, which is 231 square. The least number which is a perfect square and is divisible by each of the numbers. Number is divisible by 16, 20. Number is divisible by 16, 20 and 24, and it is a perfect square. And it is a perfect square. Number should be divisible by 16, 20 and 24. Listen carefully. 24, it is a multiple of 3. 8 into 3. 24, it is a multiple of 3. Number is divisible by 24. That means number should be a multiple of 3. 16, 7, it is not a multiple of 3. 6,400, it is not a multiple of 3. It is not a multiple of 3. So, 3,600 and 14,400. Because the question is a least number. Least number is a smallest number. Let us first check it out. 3,600. Is 3,600 divisible by 16? 16 2s are 32, 40. 16 2s are 32, 40. It is divisible by 16. 3,600 divisible by 20? Yes. 0, 0 cancel. 360 divisible by 20. 24, it is also divisible. Smallest number means I will take this number. Again I am repeating. Number should be divisible by 16, 20 and 24. 16, 20 and 24. Number should be a perfect square. 24 is divisible by 3. So, because the number is divisible by 24, answer should be a multiple of 3. 1600 not possible. 6400 not possible. 6400 not possible. Smallest number, so out of the two numbers, take the smallest, check it out. Number of digits in the square root of 62478078. Number of digits in the square root. How to find out the number of digits in the square root? Logic is simple. Start from the right hand side. Keep a slash after 2 digits. Keep a slash after 2 digits. Answer, number of blocks of 2 digits, that will be the answer. How many blocks are there? 1, 2, 3, 4. So, number of digits in the square root of this number is 4. Number of digits in the square root of this number. Fourth root of, answer is fourth root of 2401 into 4 zeros, which is 10 power 4. 10 power 4, fourth root means answer will have single 0. Answer will have single 0. Answer will have single 0. Are you all with me? Answer is 70. You don't need to do anything. So, fourth root of 10 power 4, which is nothing but 10. Answer should be having 1 0 at the end. Answer should have 1 0 at the end. Now, see here. The square root of 272 square minus 128 square. Square root of 272 square minus 128 square. How to answer this question? 272 square minus 128 square. A square minus B square. A minus B. A minus B is 144. A plus B, it is 400. So, this will become 144, it is 12. 240, it will become 20. 12 into 20, it is 240. 12 into 20, it is 240. This is the traditional method. This is the traditional method. Another method, method 2. Method 2. Method 2, unit digit logic. Method 2, unit digit logic. It is square root of 272 square minus 128 square. 128 square. 2 square, it is 4. 8 square, it is 64. 4 minus 4, 0. Answer unit digit should be 0. Answer unit digit should be 0. These not possible, these not possible. Are you all with me? These not possible. By looking at a question, I can say that 2 square it is 4, 8 square it is 64, 4 minus 4 it is 0. Answer unit digit should have 0. First option out, fourth option out. Otherwise, use the method 3. Use the digital sum concept. That is the reason each and every concept is very, very important. 272 square minus 128 square equivalent to option I will keep second one 200 square. 7 plus 2 9. 2 square it is 4. 8 plus 2 10. 10 plus 1 11. 11 is 2. 2 square it is 4. 4 minus 4 0. Left hand side digital sum is 0. Right hand side digital sum is 4. Left hand side is 0. Right hand side 4. So second option it is not possible. Here it is a very simple calculation. What if the calculation number of digits are more? It is always good to see the answer option. Method 2. 2 square it is 4, 8 square it is 64. 4 minus 4 0. Answer unit digit should have 0. So option A and option D are out. Square root I removed it and I kept it as a square in the answer option. 272 square. 7 plus 2 9 out. 2 square it is 4. 8 plus 2 10. 10 plus 1 11. 11 it is 2. 2 square it is 4. 4 minus 4 0. Answer left hand side digital sum is 0, which is 9. Right hand side it is 4. Not possible. I hope it is clear. Next one. The smallest positive integer. The smallest positive integer when multiplied by 392. It becomes a perfect square. Smallest positive integer when multiplied by 392, the product is a perfect square. Product is a perfect square. What is the logic? Perfect square digital sum is perfect square digital sum should be 1, 4, 7 or 9. Perfect square digital sum should be 1, 4, 7 or 9. Here the digital sum is 3 plus 2 5, 5 plus 9 14, which is 5. First if it is 6, 6 5s are 30, 30 digital sum is 3, it is not possible. Second option 4, 5 4s are 20, 20 digital sum 2, not possible. So here it is 5, 5 5s are 25, 7, there is a possibility. 2, 2 5s are 10, there is a possibility. But if I take 5 into 392, 5 contains 1 power of 5. Here another power of 5 should be there in the answer. Then only it becomes a perfect square. Another 392 is not divisible by 5. So D, C out. Answer is 2. Even if I do it, 2 into 392, which is 784. 784 is 28 square. 784 is 28 square. I hope the logic it is perfectly clear. So answer for this question. Similarly, you do the same logic. The smallest number which should be added to the given number such that the number is a perfect square. Such that the number is a perfect square. Just to use the properties of a perfect square. A perfect square never ends with 2, 3, 7 or 8. Second property. What is the digital sum of a perfect square? It is 1, 4, 7 or 9. Digital sum of a perfect square is always 1, 4, 7 or 9. Here the unit digit is 8. Here the unit digit is 9. 8 plus 9, 17. 7 not possible. Similarly, 17, 9. 8 plus 9, 17. 7 not possible. Option A not possible. Option D not possible. Use the digital sum. 8, 9, 5, 8. 8 plus 9, 17. 17 plus 5, 22. 22 plus 8, 30. 3 plus. If I take 54. 54 digital sum is 9. 3 plus 9 is 12. 12 digital sum is 3. But a perfect square digital sum should always be 1, 4, 7 or 9. So these are not possible. These are not possible. I hope the idea it is clear. Entire class whatever we are doing, first we are discussing the fundamentals, then we are discussing the problems where these fundamentals are used. Largest number of 5 digits which is a perfect square. Largest number of 5 digits which is a perfect square. Perfect square cannot end with 7. Option C is out. Perfect square is all when divided by 4. Either it is perfectly divisible by 4 or it gives a remainder 1. Perfectly divided by 4 or it gives a remainder 1. These 99 is 4 into 24 plus 3. Not possible. 4 into 17 plus 3. Not possible. Very simple. Perfect square never ends with 2, 3, 7 or 8. Perfect square when divided by 4, either it is perfectly divisible or it gives a remainder 1. I hope the idea it is clear. Watch the class twice, then it will be very clear to you. What number should be added to 1000 so that such that it is made a perfect square? Use the digital sum concept. 1000 digital sum is 1. X it is 10, 1. 1 plus 1, 2. Perfect square digital sum. What will be the digital sum of a perfect square? 1, 4, 7 or 9. It is 2. So this is not possible. 156. 156 is 6 plus 5, 11. 11 plus 1, 12. 12 it is 3. So this will become 1156. 1156. 1156, keep it. The digital sum is becoming 6 plus 5, 11, 11 plus 2, 13, which is 4. Possibility is there. 1000 plus 24, 2 plus 4, 6, 1 plus 6, 7. Possibility it is there. 1024. Next one, 1 plus 89, 89 it is 8 plus 9, 17, 8. 1 plus 8, 9. 1089. These also a possibility. Smallest number, if you observe carefully, 32 square is 1024. These 33 square is 1089. What is the smallest number that should be added? 24 should be added. Or what you do is, after 1 is eliminated, question is smallest number. Out of these 3, take the smallest number. To smallest number and check it out. 1000 plus 24 is 1024. 1024 is 32 square. 1024 is 32 square. I hope the logic is clear to you. Kindly watch the class again and again. How many perfect squares lie between? Lie means, between means it should be greater than 200 and less than 300. 12 square is 144. 12 square is 144. 17 square is 289. 17 square is 289. So this will be 12, 13, 14, 15, 16, 17. 12 to 17. Totally how many numbers are there? 6 perfect squares are there between 120 and 300. Greater than 120 and less than 300. 12 square is 144, which is greater than 120. 17 square is 289. So 12 to 17. Totally 6 numbers are there. I hope it is clear. So what we will do is, in our next class I will take it at night 10 p.m. In night 10 p.m. I will discuss some advanced level questions. I will discuss some night 10 p.m. I will schedule the class right now. Night 10 p.m. we will discuss perfect squares session 3. Perfect square session 3. We will take the questions to an advanced level. Any student who is watching this session, in case from January 1st onwards, topic wise classroom, weekly, how many hours, everything will start from January 1st. Anybody who want the thematic based learning, you can always join the course. Thanks a lot for watching the session. Once the video is processed, kindly watch it again before session number 3 so that you will be very comfortable when we are solving advanced level problems. Thank you. With love, Anil Nair.